Have you wondered why the path of a basketball, or when you throw a basketball into the court, the curve of the basketball, the path of the basketball is so curvy? Uh, Other than if the pendulum start to move. So have you noticed the path of the pendulum moving in its curvy path? Actually, these two are the example of quadratic motion. What is quadratic motion? Actually, the a moving body that is going through a parabolic pathway is a quadratic motion, and the quadratic motion is denoted by the quadratic equations. And we all know the quadratic equation to x squared plus bx plus c. Okay, so today the focus topic will be the quadratic graphs that is generated by quadratic equations. Okay, and we will try to identify a graph just to a b a b c. So let's get started. So first of all, we have to know about the root of polynomials. So if we say that f of x is equal to ax squared plus bx plus c, then the root of the polynomials will be x is equal to minus b plus minus root over b squared minus 4ac divided by 2a. We all know that. And when we will try to know about the graphs, we will always consider it as a real number graph. And the root of the polynomial will be rational. And if we want to have the rational root, we have to meet this part of this equation, that which is d is equal to b square minus 4ac must be greater than or equal to 0. If we want to we have the roots of polynomials rational. And to simplify the topics, we will always consider the graph as a rational root. So actually, there are many conditions of while d either greater than or equal 0, d less than or equal 0, less than or equal no, d is equal to 0, and when d is greater than 0, d is sometimes a fully squared number, and so on. These are some of the complex things. Okay, but we have to first identify how we have got the roots of a polynomials. So if we just draw a normal polynomial graph or quadratic graph, we will get this. Okay, and these 2 points which is above the x-axis will be considered as the root of the equation. How will get that equation? We all know that the value of y on the x-axis is always 0. So if y is equal to 0 for all the values of x-axis, then we can say that ax squared plus bx plus c equal to 0. And by solving this equation, we get that x is equal to minus b plus minus root over b squared minus 4ac divided by 2. Right? Okay. So we throughout this video we will talk about the normalized graph, which is like that, or that the graph can be like that, or this, and this like that. Okay. First of all, if we got the two x's and which is 0 x axis and y-axis. So we have to find that either the direction of the parabola. We have written here the word parabola. That is mean this means actually the quadratic graphs. The quadratic graphs are parabolic. Okay. Either the parabola is situated on the right side of the left side, and the opening of the parabola is toward the positive side of y-axis or the negative side of y-axis. So how we can diagonist that? So we will get an equation y is equal to ax squared plus bx plus c. So if if we see the constant a, and a cannot be equal to 0. Why? If a is equal to 0, the equation will be no more quadratic. It will become a linear equation. Okay. But if a is greater than 0, then the graph is upper. The opening of the graph will be at the upper side or the positive side of y-axis. Upper side, y positive side of y-axis, right? Upper side or positive side of y-axis, and uh, y-axis. Okay. And actually, how we can show this, like the graph will be like this or this, right? We can see that the opening of the graphs are toward the positive side of y-axis, right? Okay. Now, you can memorize it, or you can remember it, like if a is equal to 0, then if a is greater than 0, then the graph will be like a happy face. Like this is a face, or the happy face is denoted by this like of signs. In contrast, if a is less than 0, the opening of the graph is at the negative side of y-axis. You can like now can imagine a graph or can assume a graph like this or like this. Right? And you can see that the opening of the graph is toward the negative side. And you can also remember this by remembering that if you got a quadratic equation which the constant a that is multiplied by x square is negative, then the graph will be like a sad face, like a sad face. The sad face is denoted by this. We all use emojis. We have if we want to understand the concept of line of symmetry, we have to understand the concept of parabola. Right? If we draw a parabola parabola is actually a symmetrical graph, and the symmetrical line is between its middle section. Okay, the line here is called the line of symmetry. Line of symmetry, right? So if we denote the line of symmetry, either the line of symmetry is at the positive side or negative side, we can denote the graph whether it is on the positive side of x-axis or negative side of the x-axis. X-axis. So this is like that. Like either this line is a line of symmetry of a graph, or this line is a line of symmetry of a graph. And if we determine that either the line of symmetry is on the positive side or the right side, or the negative side or the left side, left side, left side, left side, we can determine the graph either the graph is on the positive or negative. Okay. Now, 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 how we can determine the symmetry, line of symmetry or vertical point? Okay. So to understand the line of symmetry of a parabola, we have to know the concept of vertical point or turning point, right? So how we can calculate the vertical point? So we have to do some calculus here. We know that y is equal to ax square plus bx plus c. Now, if you get a graph of quadratic graph, the point here is called the vertical point or the turning point, right? And we know this is also called the highest point of a graph, right? Highest point of a graph. Okay. So how we calculate the highest point or maximum point of a graph? We actually got dy by dx equal to 0 here. That means the change of y with respect to x is 0 here. Okay. So if dy divided by dx is equal to 2ax plus b equal to 0, then x is equal to minus b divided by 2. What is that? This is actually the equation of the line of symmetry. Okay. Okay. Now, now here we can see that the equation of line of symmetry is negative by its physical values. So if a and b having the same sign, like both having positive, or both having negative. So two positive numbers ratio is always positive, and two negative numbers ratio is always positive. So if a and b having the same sign, that their ratio a divided by b divided by a is always positive, right? Okay. So as we can see that the physical sign of x is negative. So if b by a is positive, then x is always negative. That means the the graph is situated on the left side of a x-axis, right? The graph will be this or this. Okay. Then if a and b having opposite sign, that a and b must be plus, minus, or minus, plus. So the two opposite signs numbers ratio is always negative. So if b by a is always negative, then the sign of x is always positive. That means the graph is situated on the right side of a x-axis, right? So from this video, we have seen the sign of ABC. Then if we have a equation like f of x is equal to minus 2x squared plus 5x plus 3, here we can say that first of all, if a is less than 0, then the opening of a parabola is at the negative side. That means the graph might be this or this. Okay. Number second, if a divided by b is negative, that means the graph is obviously at the right side. That means the graph of this equation or polynomials f of x is equal to minus 2x squared plus 5x plus 3 is either this or this. So we can denote a graph by only observing the signs of the constant of a polynomials equations. Thanks for